Okay, hello everyone. This is a supporting video for the example of this example of 10.5 on textbook. Okay, and in the last video, I calculated the angle of twist of A with respect to D and angle of twist with respect to C. And when you check the textbook, you will find the textbook answer is the magnitude, the value is the same, but in the textbook, there is no negative sign. Okay, so in the textbook, the answer is 0.007212, and the AC is 0.008482, and there is no negative sign. But my answer has a negative sign. So that means I have to use this problem to explain the sign convention issue. Okay, and yeah, actually the sign convention issue is very annoying in mechanics of materials. Okay, so here is the sign convention for a torsional load member. So I just show this slide. I don't keep the slide here. Okay. Here. Okay, so here's the convention for the torsional load member. Okay, so if you use the right hand rule, that means right hand rule that if you torque, you use the right hand rule, your forefinger is the direction of torque, and your thumb, if your thumb point out of from the bar, that means positive. So and so if your thumb point into the bar, that would be a negative. Okay, so this is a sign convention of torsional load member. If your thumb point out of the bar, positive. If your thumb point into the bar, so that's the negative. Okay, so let's back to the example 10.5 here. Example 10.5 here. Okay, here is our calculation result. Yeah, we use the cross-section method and compute the torsion of each section. So here is our value. Okay, our torque AB is minus 80, BC is 70, and CD is 10. Okay, so so initially we assume the torque is counterclockwise, but we have the negative value. So that means the real direction is the real direction is clockwise. The real direction is clockwise. Okay, so here the real TAB is here. Okay, so and the TBC and TCD initially we assume is counterclockwise and get a positive value, so that's what it means it's really counterclockwise. So we only have to do modification is here. Okay, so TAB. Okay, TAB. Okay. And so then we put this TAB, TBC, and TCD into the angle twist formula, and okay, we will have the phi AB is negative, phi BC is positive, phi CD angle CD is positive. Okay, and now but at that time I didn't consider the sign convention, so after that I have to use the sign convention to correct the angle of twist. Okay, let's see here. Okay, TAB. So the torque is here. So you use the right hand rule. So you will find your final torque is point out. Your final torque is point out. Okay, see. Your final torque, the thumb is point out. Use the right hand rule. Your final torque is point out. Is point out. Okay, so that means the angle of twist positive. Positive, and here is the right hand rule. It's point in the bars. Okay, it's away from the bar. I need to draw this better. Okay, so for the torque AB, it's point out from the bar. So and the DBC is point into the bar, so it's negative. And here CD, use the right hand rule. It's point is your thumb is pointing into the bar. So finally, the correct if you use a sign convention, so this will be here. This positive. This will be negative, and this will be negative. You will find that my answer is the value I calculate is all correct. The only difference is the sign. Okay, only difference. My calculation results. The only difference between my calculation result and textbook is just the sign. Okay, it's just the sign. Okay, and the value is my value is the same as the textbook. So that's not really a big deal. I just hate the sign convention in mechanics of material. Okay. So if you calculate the value is the same as the textbook answer. That means your calculation actually is correct. And you have different sign with the textbook. That's just because you didn't apply the sign convention in the textbook. If your value is the same, that means your calculation is correct. But if your sign is not the same as the textbook, that just means you didn't apply the sign convention from textbook. Okay, so I have to use this short video to explain this. My calculation process is all correct. Okay, but finally, yeah, we still have to kind of follow the textbook sign convention, right? Okay, so here's a video for sign convention issue for 10.5. Okay, so see you in another video. Okay, bye bye.